Welcome to physics class. My name is Babalola. I'm here to teach you dimension. At the end of the lesson, students should be able to derive the dimension of some physical quantities and also to state two uses of dimension. What is dimension? The dimension of a physical quantity is the expression which shows how the quantity is related to the fundamental unit from derived units. And in physics, the dimension for length is given by L, and that of mass is given by M, and that of time is given by T. Let's take work example. Example 1, area. We all know that area is given by length times breadth, and the dimension for length is L. And take note, anytime you have length, breadth, height, distance, displacement, they are all given by L. So therefore, length is L and breadth is also L. So L times L will give us L square. Volume. Volume is given by length times breadth times height. And we know that length is L, breadth is L, and height is L. Therefore, we have L times L times L, giving us L cubed. Density. Density is given by mass divided by volume. And the dimension for mass is M. And the dimension for volume, we have done this before, is L cubed. So density is M divided by L cubed, or ml raised to power of minus 3. So the next one is speed. Speed is given by distance divided by time, and the dimension for distance is L, and the dimension for time is T. Therefore, we have speed to be L over T, or LT raised to power of minus 1. Next is velocity, and we know that velocity is displacement divided by time, and the dimension for displacement is L, and dimension for time is T. So we have L over T, or LT raised to power of minus 1. Acceleration. We know that acceleration is given by increase in velocity divided by time, and we have done velocity before, which is L over T. So velocity L over T, and time here, which is T. Then if we do that, we can say L over T divided by T, and we can change this division sign by multiplication. If you do that, we have this, it will be L over T times 1 over T. And we know that L times 1 is L, and T times T is T square. So acceleration is L over T square, or LT raised to power of minus 2. Force. Force is given by mass times acceleration, and the dimension for mass is M, and the dimension for acceleration is L over T square. So M times L will give us ML over T square. So ML over T square is the dimension for force, or ml T raised to power of minus 2. Next, momentum. Momentum is given by mass times velocity, and the dimension for mass is m, and we know that velocity is L over T. Therefore, m times L is ml, then divided by T. So momentum is ml over T, or mlt raised to power of minus 1. Impulse. Impulse is given by force times time. And we know that force is ml over t square. That is force, then times time. The dimension for time is t. Therefore, ml times t will give us mlt. ml times t will give us mlt divided by t square. So we can see that this t at the numerator can divide the t at the denominator. So remaining t at the denominator. So it now give us ml over t. So impulse is dimensionally given as ml over t, or ml t raised to power of minus 1. And we can see that the final answer for momentum ml t minus 1 is the same answer for impulse ml t minus 1. So they have the same unit, they have the same dimension. So next is moment. Moment is given by force times perpendicular distance. And we know that the dimension for force is ml over t square. Then times perpendicular distance, same as dimension for distance, which is L. Therefore, ml times L will give us ml square divided by t square. So moment will give us ml square divided by t square, or ml square t raised to power of minus 2. Work or energy mathematically is given by force times distance, and the dimension for force as usual is ml over t square times the dimension for distance, which is L. Therefore, ml times L will give us ml square divided by t square. So we now have work or energy to be ml square over t square, or ml square t raised to power of minus 2. Power. Power mathematically is energy divided by time, and we all know that the dimension for energy, we have done that before, which is ml square over t square. So which is this ml square over t square divided by time, is the time t. So if you do that, we have ml square over t square divided by t, divided by t. So we can also change this division sign into multiplication, and if you do that, we are going to turn this to be 1 over t, as you can see. Okay, so if you do that, ml square times 1 is ml square, t square times t is t cube. So power is ml square over t cube, or ml square t raised to power of minus 3. Pressure is given by force acting normally in a unit area, or force divided by area, and the dimension for force is ml over t square. ml over t square divided by area. We know that area is length times breadth, will give us L square. So we can also put it in this way, ml over t square divided by L square, as you can see. So we can also change this division sign to multiplication. So we will invert this. So we have ml over t square times 1 over L square. So ml times 1 will give us ml. T square times L square will give us t square L square, or L square t square. So if you now have that, you can also see that this L can cancel this L square here. So it will remain 1L, why this one will go. So we now give you m over L1 T square, or m over L T square. So pressure is dimensionally represented with m divided by L T square, or m L raised to power of minus 1 T raised to power of minus 2. Uses of dimension. 1. It is used in checking the validity of an equation. 2. It helps in recalling important formula. 3. For solving physical problem theoretically. So let's take this test at your leisure time. And this